Hey everyone, welcome back. In this video, we are going to do the FRQ from the year 2000, question number 5A. So this question does require knowledge of implicit differentiation, which is usually introduced in Unit 3. And let's go ahead and jump right in. So the key thing with implicit differentiation is to remember that every time you take the derivative of y, you have to put dy dx after it, and all of your other derivative rules apply. So with that little caveat, let's go ahead and jump right in. Let's start with this term here, our xy squared term. This we are going to have to use the product rule for. So I kind of have that memorized as the first times the derivative of the second, remembering to put dy dx after it because we took the derivative of a y term, and then plus the second term times the derivative of the first. So, and you may have that memorized slightly differently. That's just kind of what's stuck in my head, but of course, feel free to use whatever product rule you have memorized. Okay, and then moving on, let's do this again. So I like to consider this minus sign attached. Again, personal preference. So I'm going to do first times derivative of the second, which is just dy dx, plus the second times the derivative of the first, which would be negative 3x squared, just using the power rule there. And then equals the derivative of 6 is just 0. So now I'm just going to go ahead and clean this up a little bit. And then from there, I'm going to kind of rearrange all of my terms, keeping my dy dx terms on the left, and I'm putting everything else on the right. So this I'm going to rewrite as 2xy dy dx, and then plus, I'm just going to write that as y squared. Here, this is going to be negative x cubed dy dx. And then here, this is going to become negative 3x squared y equals 0. Now I'm going to group everything with dy dx on the left. So I'm going to rewrite it as 2xy dy dx minus x cubed dy dx. Now I have this term and this term that I'm going to bring over to the other side of my equal sign. So I'm going to add this 3x squared y first to both sides. So I'm going to get 3x squared y, and then I'm going to subtract y squared from both sides. So minus y squared. Now I have to go ahead and factor out dy dx on the left-hand side. So dy dx times 2xy minus x cubed equals 3x squared y minus y squared. Now I'm going to go ahead and divide by this on both sides. So divide by 2xy minus x cubed and divide by 2xy minus x cubed. Just rewriting that quickly, I got 3x squared y minus y squared over 2xy minus x cubed equals dy dx. So now let's go ahead and just verify that. It's asking us to show that that is in fact dy dx, and that is exactly what we got. So we have successfully confirmed dy dx using implicit differentiation. Thanks so much for watching.